In this video, we're going to discuss elasticity of demand. Elasticity of demand is a way to measure how changing price affects the demand that will be placed on a certain item. And so the idea is that changing price of certain items does very little to the demand of some of them, while in other items, changing the price greatly changes demand. So the example that I've given here is that everybody needs light bulbs for their house, restaurants, things like that. So changing the price of light bulbs does not greatly change the demand. However, changing the price of something like, say, a Honda Civic or another make of car would greatly change the demand for that car. And the reason is that there's many options available. For instance, if Honda was to raise their price by $3,000 or $4,000, much less people would be willing to buy this car. However, these aren't always just an apples to apples comparison. So we want to look at things as percent changes. For example, if you change the price of the light bulb by $50, obviously nobody would purchase the light bulb for that amount of money. That seems crazy. But changing the price of a Civic by $50 would probably not sway somebody from making that purchase, because a Civic costs a significant more amount than that. So what we want to do is look at percent changes. So what we do to do this is we look at what we call elasticity. So we're going to let P be the price and delta P be the change in price, and Q be the quantity and delta Q be the change in quantity. Then we say elasticity of demand is approximately the percent change in demand, which is delta Q divided by delta Q divided by Q, over the percent change in price, which is delta P over P. Or if we really wanted to be precise, if we had a function, we could actually use this method over here, which is to do the absolute value of price divided by quantity times the change in quantity as the price changes, or the derivative of quantity. And that would provide us absolutely the exact elasticity of demand. So if we have a function, we can use this one. It all just depends on the given information. So how is this helpful? Well, if E, the elasticity, is greater than 1, a 1% increase in price will cause demand to drop greater than 1%. We would say that this is elastic. This means that a fairly small increase in price is going to greatly affect the demand. It's going to cause it to decrease. If elasticity is between 1%, an increase in price causes a drop in demand less than 1%. So we call this inelastic, and that means that a small change in price does not really affect demand. If we want to look for the specific percent change in demand, if you think about what's happening in the problem, if you cross multiplied, you would see that the change in demand equals elasticity times the percent change in price. And this allows us to show kind of specifically the percent change, or what we expect to happen to demand given the elasticity of an item. So here we go. Here's an example where we're only given numbers. We're not actually given a function, and we want to compute elasticity. So this says raising the price of hotel rooms from $75 to $80 per night reduces weekly sales from 100 to 90 rooms. And so if you think about hotel rooms, my guess is that this is going to end up being something that we would consider elastic. And the reason is, typically we have options for hotel rooms. There's multiple places that we could stay. And so if one's significantly more expensive than the other, we're probably not going to choose to stay at that hotel. So let's look and see if that's the case. So we're going to approximate the elasticity of demand for the hotel rooms from $75 to $80. So let's get all of our variables and figure out how we're going to compute this. I would say for P, the price, we want to consider the starting price, the price we're changing from. So P here is $75. Delta P is the change in price. Well, we're going from $75 to $80. So the change in price, 80 minus 75, is showing a $5 increase in price. The quantity, the number of rooms sold at $75 was 100. And the change in the number of rooms sold, well, if we were at 100 and we go to 90, that would actually be negative 10. So the change in the rooms is actually a drop in 10 rooms. So to compute elasticity, we're going to do the absolute value of delta Q over Q. Negative 10 over 100 divided by delta P over P. 5 over 75. That equals the absolute value of negative 0.1 divided by 0.067. And the absolute value of this division comes out to be 1.5. So E equals 1.5. Should the owner raise the price? Well, if E is greater than 1, he should not raise the price. So no, since elasticity, E, is greater than 1, he should leave it. All he's going to do is decrease his demand greatly, not enough to justify the increase in price. If the owner changed the price by 10%, let's change this. What change in demand should he expect? Well, we have a formula for that. That percent change in demand equals elasticity, which we computed as 1.5, times the percent change in price, which for our problem is 10%. So he would expect 1.5 times 10%, a 15% change in demand. So a pretty great change. Okay, in this example, we're going to look at a function and what happens when we want to solve these sorts of things from a function. And so recall, in this instance, elasticity equals price divided by quantity times the derivative of quantity, dq dp. So what we want to do first is to do this change, we need to figure out what is dq dp. Well, if P equals 90 minus 10Q, to do the derivative, we really need this function in terms of Q. So I want to solve for Q. P minus 90 would equal negative 10Q if I subtracted 90 over. And dividing by negative 10, everything by negative 10, we would get negative 1 over 10P plus 9 equals Q. So far we have Q equals negative 1 over 10P plus 9. Taking the derivative, dq dp, the derivative of negative 1 over 10P is negative 1 over 10, and the derivative of 9 is 0, so dq dp is negative 1 over 10. The other things we need are P and Q. Well, if P equals 60, and 60 then would equal 90 minus 10Q, we need to solve again for Q. So negative 30 equals negative 10Q. If I subtracted 90 over, I would say Q equals 3. So now we have Q, P, in dq/dp, I would say elasticity equals the absolute value of P over Q, 60 over 3, times dq/dp, negative 1 over 10. E equals the absolute value of 20 times negative 1 over 10. This will come out to 2. So E equals 2. So if the price rises by 3%, what percent change would we expect in demand? Similarly to the last problem, we know percent change in demand equals elasticity times the percent change in price. In other words, we would expect a 6% change in demand.